This week, HVAC 360 salutes Trane. In addition to making world-class products, Trane offers a wealth of opportunities and resources for everyone in the HVAC field. From articles like the Trane Engineers Newsletter to application manuals or training classes, they have in-depth information on numerous topics, from basic HVAC design and operation to controls. Thank you, Trane, for all that you do. Hey everybody, welcome back. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in the field of HVAC. I do that either by sharing information or specific lessons learned from the field, or in general, just talking with industry experts. If you haven't already, I want to encourage you to double down on your weekly helping of HVAC knowledge by going on over to HVAC360.com and joining my growing community of people just like you. Sign up for that newsletter. All right, so why Trane? I kind of explain a little bit of why I salute certain manufacturers. And besides the great products, the great local reps, a factory tour, I think one of the biggest reasons, is the educational information they share. Doing some things locally, doing webinars, and they have a great training class. This is a training class that's kind of extended. It's one of the few that are out there that are like a multi-week, multi-evening training course. It's really great because it not only helps you as a engineer, but anybody else who's interested in learning more about HVAC. It's kind of off hours. It's second shift. So they do that periodically. It's not free, but it certainly is worth it if you need a head start understanding this field. So what's up for this week? This week I wanted to get back to some basics with fan types. Now, I know HVAC works on the principle of moving heat around. We do that with using some sort of medium like air, water, and refrigerant. And don't get me started on classifying water as refrigerant. I know you're just confusing people. It doesn't need to be done. So to move these mediums, we have devices that help us. So for instance, water, we use pumps. For refrigerant, we use compressors. And for air, we use fans. So today we're going to be talking about fans in general. So why do we need to know this? It really helps to understand the pros and cons of different systems, different fan types, and also to be able to identify fans in the field. So, generally speaking, when you talk about the major components of the fan, you're going to be talking about the impeller, that's the wheel part. You're going to talk about a motor, which basically spins the impeller, and you're going to be talking about a casing. Generally speaking, most of these fans have some sort of casing. When we talk about the motor, different options you're going to see. You're going to have, typically, you're going to run into a belt drive. That's going to be your more traditional case. Or you're going to have a direct drive where instead of having a pulley and belt system that allows you to kind of change the CFM and the speed of the fan, you're going to have a direct drive fan, which is directly coupled. It's more like a pump where it's directly coupled to the impeller, going through the airstream. Now, some of those drives you can have in the airstream. A lot of the direct drive fans are going to be in the airstream, and some of them you can have outside of the airstream. Now, that's kind of important when you talk about the type of air that you're dealing with, and we'll kind of go through that a little bit later. Obviously, when the different component with the casing, this actually helps direct the airflow, especially when you're talking about the centrifugal type wheel. That's going to be key in being able to direct where that air is going. Now, let's talk about that third component, the impellers. Generally speaking, it falls into a couple different categories. I guess the important ones that you want to focus on when you're just starting out, you want to be able to focus on the centrifugal That is the wheel type. And when you're looking at it, the way it works is that air comes in at the inlet. That's at the center of the wheel, and it turns 90 degrees, and it gets forced outward. So it's going to take a 90-degree turn and get forced out. Typically, it's going to take another 90-degree turn and continue on its merry way to the rest of the system. So that is a centrifugal wheel. We're going to go talk about that a little bit more. The second type that you're generally going to see is you're going to talk about the axial. This is going to be more of the propeller type that you've seen in a lot of applications. In fact, most movies. Check up on my podcast that I did a while ago on Stranger Things. And this is actually a straight-through application. There are others that are out there, combinations, mixed flow fans, different other specialty fans that you're going to be dealing with. But really, if you understand the two, centrifugal and the axial, you're going to understand probably 90% of what you're going to see. All right, so let's start with the centrifugal. All right, I'm having a real tough time saying that centrifugal part. These generally are going to be ducted. Mostly they're going to be ducted. And they're coming, generally speaking, they're going to come in 4 different varieties that you're going to see on a day-to-day basis, regular day-to-day basis. So the very first one that you're going to probably see is you're going to see a backward incline. This is where the blade is kind of more or less just as it spins, it's kind of slapping at the, slapping in a kind of like a backward fashion as it rotates. You can also get a backward curved, so instead of it being flat, it can be curved slightly. Those are pretty much the workhorses of the industry. When would you use them? Generally speaking, again, you're going to see them a lot in air handling situations where we have high pressure, so high static pressure, and you need a lot of CFM. The backward inclined of the set is very economical. Not as economical as like one of the others that I'm going to mention, but it's more economical than the next one, which is the backward airflow. Now, again, this is still the blade type is still backwards, but it's going to be an airfoil design. So backward airfoil, and again, that's going to be high pressure, high CFM. It's more efficient and quieter than the backward incline, but it's typically going to be a higher end model. Of the 4, you really don't see those too often, but you still see them out there. The next one is a forward curved fan. Now, this is the cheapest one of the bunch. They're kind of nicknamed the squirrel cages. They're hard to clean. The rest of them you could probably dust off and clean pretty easily. This one is not, because you generally speaking can't get these forward curved blades. They're very, very hard to get in between. They're spaced narrower than most fingers. So if you do, you're gonna use a tool. Don't use your hand. Generally speaking, they're quiet. They're economical, but they don't have a lot of static punch behind them. You're gonna see these a lot when you deal with cabinet unit heaters. VRF evaporators, so the indoor unit. You're going to deal with these with the mini splits. Again, the evaporator section, and toilet exhaust. So a lot of times when you see a little spinning squirrel cage or a hamster wheel, that is going to be a forward curved fan. Now, the last variety is kind of it's a plug fan. So whether you're dealing with a backward inclined or an airfoil, generally speaking, a plug fan is one of those two without the casing. So it's very closely coupled. You have the inlet to the fan on one side, and then it just kind of radiates into a plenum on the other. So it generates the static, and all these do is create a differential pressure across the fan. They impart energy in the system, and so it pressurizes the discharge side So you can basically, what you end up doing, and is that you can end up tapping that plenum box at any location, and air would start flowing because it's a pressurized situation. Now, a lot of times you're going to see these in fan wall configurations. These have become more and more popular with fan walls. And the one thing that I'll point out, a lot of times I see these being driven past 60 hertz. So that's just something to be aware of. And, the commissioning authorities in the room, a lot of this, when it's over 60 hertz, it may not necessarily get set up properly. So you want to pay attention to at what hertz rating it was set up. A lot of these, some of the default settings in the VFDs that are going to be driving these fans aren't going to be set up correctly. I've had a couple cases where that's been not the case, so just be aware of that. Now, on the other side, axial, a lot of these, remember, again, this is the propeller type. And really, the propeller types, mostly they're going to be unducted, probably 99% of the time, because that is their shtick. That's what they do. They do high volume, low static. And they are definitely considered more loud than the centrifugal fans. So that's something you're going to be wanting to pay attention to. But generally speaking, these type of devices, they're going to be mounted in walls. So whether you're in a mechanical room or electrical room, or possibly even a garage where you have to ventilate a certain area, that's where you're going to find these types of fans. There are different types of axial fans. There are tube axial and vane axial. These are actually mounted in a tube. Ironically, that's in line with their name, and they're usually in ductwork. So a lot of times you would see those type of fans in that situation. But again, they're the axial type. They just have more blades, and the motor tends to be bigger, a bigger percentage of the cross-sectional area of the tube. So take a look at that. But generally speaking, propeller fans, that's going to be, hit or miss. A lot, in kind of going through both of these, probably 90% of what you're going to see is going to be the centrifugal. You're not necessarily going to deal with the tube axial, vane axial. You might deal with the propeller type more, but again, it just comes down to those common uses. Now, as far as selection goes, you're going to have to know your CFM, which generally is pretty cut and dry. What you may not, you need to focus on a little bit is whether or not it's going to be a constant volume or it's going to be variable volume, depending on your situation. You're going to want to know the static pressure. A lot of times, and that's one of the things that you is a little bit more important when you're learning to lay out different fans and ductwork configurations, the inlets, the outlets. You're going to have what's called system effect, and system effect is going to dramatically affect the static pressure that fan will see. Now that's going to impact its performance. So again, to be able to select the right fan, you got to know the static pressure. So school up on that a little bit, static pressure, system effect, and being able to calculate that, or at least guesstimate that, even if it's a little bit conservative. Now you want to be able to be, as far as selection goes, you want to understand the mounting of it. Is it going to be on the roof? Is it going to be an inline fan? This is especially important, when it comes to some of the tips that I'm gonna mention. Options. You want to know, especially controls. How is it controlled? Does it have a VFD on it? How is that going to be interfaced? Who's going to supply the VFD? Is that going to be the electrician? Is that going to be the mechanical contractor? Who's going to connect to it? How does it connect to the control system? What type of coatings are there? Because, and this kind of relays into a point that we've circled around to, it depends on what the air is. So if you're just generally dealing with common air, whether it's normally heated or cooled, you don't really have to, you know, pay much special attention to it. But if you start to get into dirty air, and this is more of some industrial applications, or if it's air that might be coming from a grease duct, so you have some particulates in there that are going to affect the performance of it. Is it going to be hot? Is it going to be humid? Do you have a coastal region that you have to account for? Again, this is kind of calling back to those coatings, where you're going to have some of the hair side coatings to prevent rusting on the fan wheel itself. So is that something that you need to account for in your selection? Now, as far as some tips that I'm going to leave you with, you got to know how the fan is going to be maintained. If it's going to be a belt drive, you're going to have to, change the belt. You're going to have to be able to grease the bearings. Some of the direct drives don't necessarily get greased at all. Some of them do have fittings, so you have to know, where the bearings are, how they're going to be greased, and is it accessible. So obviously know where your ceiling is, and know if you're going to put an inline fan above a ceiling, how far. Also, you want to be able to know where the outlets are going to be relative to the inlets. This kind of calls back to your 10 feet clearance between exhaust and intake. So you got to make sure that, depending on what kind of fan you're setting up, you want to make sure that it's leaving in the right location. So you need to be able to pay special attention to that. Know if there is noise. If there's a lot of noise, is that going to be an issue with some adjacent spaces? Do you have a plenum that's going to be sealed, that's going to isolate from the rest of the adjacent spaces? Or is the plenum space all open above the ceiling? And is that going to affect those adjacent spaces? So you really have to understand, what does it look like above the ceiling if you're going to have something that's going to be above an inline fan above the ceiling. How is the system going to be balanced? Does it serve multiple spaces? I had a project just recently that had a single fan that pulled air out of two adjacent rooms, but there wasn't any sort of balancing dampers or control dampers that was part of the installation, and it became a really problematic situation. You want to be able to review your control sequences. So for every fan that you have, whether it's going to be a bathroom fan, whether it's going to be exhaust fan, supply fan for a air handling unit, or a return fan, you want to be able to understand that each of those has a specific sequence. So when you're reviewing your drawings, you want to make sure that everything has a control sequence. And the last tip I have is get to know your local reps. Review the fan curve. That's one of the things. If you don't have a real fundamental grasp on fan curves, and fan curves are really, at what point are you going to select a fan? That's where your CFM and your static pressure meet. It's going to be somewhere on that fan curve. And realize that fan curves can take different shapes. There could be a kind of what is referred to as kind of a preliminary dip before it gets onto the main slope of the curve. And what happens is that, if it's not, and I guess this is probably easier to explain visually, but if you have a fan curve that starts up high, and as it increases in CFM, the ability to affect static pressure goes down, so it's kind of like a nice round hill. If there is a dip in there as it goes down, that's going to be an area that you want to avoid selecting anything at. What that basically means, and this is kind of a weird phenomenon that it was really kind of interesting to me when I first discovered it, but you could have a fan that is and it's really the same static pressure. So there's 2 points on that fan curve with the same static pressure, but different CFMs. And there's really no way to differentiate, without, adding, a lot of extra cost to the project, exactly which one of those points you're going to be operating in. So you want to be able to avoid that and kind of select it down further on that fan curve. You want to get away with that. Not all fan types have that dip, but that's why you want to be able to kind of review that with your manufacturer's rep, because understanding that is going to be important when you're doing the static pressure calculations. If there is some system effect that kind of backs you up the curve, all of a sudden that could throw you into a case where you're selecting a fan in a poor location. So some of your estimations, you want to be able to make sure that you're close enough to a right answer that keeps you from an unstable, selecting an unstable condition. And by reviewing that with your local rep, that's going to be able to help you understand exactly, where the fudge factor is, where you can make sure that you're selecting it at the right point. All right, well, that's it for this week. Thanks so much for listening. I hope it was helpful. If you know somebody who's looking to step up their HVAC game, consider sharing this episode or really another one of your favorites with them. This is by far the best thing that you really can do for us to spread the word about the podcast. For those of you who want extra credit, we have 3 simple tasks for you. If you're not a subscriber, go over to HVAC360.com and sign up now for some more weekly goodness. So go subscribe to the YouTube channel. Just look up HVAC360.com and sign up there. And lastly, I'd be greatly honored if you would consider leaving me a 5-star review over at Apple Podcasts. Well, that's a wrap for this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.